Hello, everybody. Welcome to lesson 3.5 in our textbook, and it's on page 156. And this lesson is on isosceles. Isosceles and equilateral triangles. And what we're learning is how to use and apply properties or rules of isosceles and equilateral triangles. So first of all, what is isosceles triangle? An isosceles triangle has minimum of two equal sides, and you can show that with the tick mark, and the other side is different. Hang on, my machine is messing up. So, come on. Sorry, guys. Let's fix that. There we go. So two equal sides, and the angles, these are called base angles, and they're on the bottom. If you think of this side here, the one that's not equal, as the base of the isosceles triangle, these are called base angles, and they're equal. Yeah, see, that's why they only have one bow. This top angle is called the vertex angle, and it's a different size than these two. But remember, the sum of all three interior angles of any triangle is always what? We learned that it's always equal to 180. So if you know two angles, you can always find the third angle by adding the two you know and subtracting that sum from 180, and that gives you the third angle. So that's what we're going to do today. So this is isosceles. It's a Greek word, isosceles. No, wait, I made a mistake. First, we have to learn how to write it, right? There, oh, am I going crazy? There is an S. Isosceles. There we go. Triangle. And then we're talking about equilateral triangles, and the word lateral in Greek language means side. So lateral, equal, means all sides are equal. So let's see how we show that. I'm going to try to make it look like all sides are equal. That didn't go over too well. I think the minute the internet lags, my marker doesn't work. So remember, the sides are shown by these dashes or tick marks, as I call them. All three sides are equal, and that also means that all three angles are equal. That's called equiangular and equilateral triangle. Now think about it. If you know that all three angles are equal and their sum is 180, what do you suppose each angle measures? So if you thought about it for a minute, you probably figured out that each angle has to measure 60 degrees in order for them to add up to 180. So yeah, in an equilateral triangle, all angles equal 60 degrees always. And I think that's coming up at the end of this lesson. So I'm not going to write that down. Excuse me. Let's read the essential understanding. Always refer back to your notes when you do your homework or quizzes you want to study. These boxes kind of hold all the information that you really need to know. The angles and sides of isosceles and equilateral triangles have special relationships. Isosceles triangles are common in the real world. You can frequently see them in structures such as bridges and buildings. Start looking for them. What does this look like? It looks like the roof of a house. Trusses are looking like that when you see the wooden trusses that make up the roof of a building or a house. Yeah, usually it's an isosceles triangle. And it's also in art and design. The congruent or equal measure sides of an isosceles triangle are called its legs. So that's a word we need to know, legs. So this is a leg right here. And this is a leg. So the congruent sides are called legs. Oh, there we got the little word. The third side is called the base. So that's the base is the part that has those two equal angles. And it's the third side. Yeah. And when you work out these questions, sometimes the triangle is tilted and it makes it not quite clear which one is the base, because you're thinking base must always be on the bottom. Not so. Sometimes our triangles are tilted sideways, and you have to realize that the base is the one opposite of the vertex angle and with the two equal base angles. Okay. The two congruent legs form the vertex angle. This is your vertex angle up here. Yeah. The two congruent legs form the vertex angle. So that's another word we need to know. The other two angles are called the base angles. Base angles. So now we should know all the parts of an isosceles triangle. Make sure you refer back to this when you work on your assignment. And let's read this theorem. That's called the isosceles triangle theorem. And it says, if two sides of a triangle are congruent, like this, I'm going to make that bigger. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. So these two sides congruent makes these two angles congruent, the base angles. That's what this says. Okay. And then, so let's put read here so you can remember to study that. Whoops. Okay. Then let's move on to page 157. And in the middle, we have another theorem, and this is the opposite. It's called a converse. Converse means it's backwards or opposite of what the other theorem just said. If the two base angles are equal, then the two sides are equal as well. So it's kind of backwards. If two angles of a triangle are congruent, like these two, then the sides opposite or that hold this together are also congruent. Yeah, converse, it's just the same one backward from the last theorem. Come on, little marker. Okay, so we also want to read that. All right. And now on the bottom here, I want to do this problem number 1 with you. And notice we have a whole bunch of stuff going on. So sometimes we have to be able to discern what we got. 1, 2, 3 triangles. And this right here is not a triangle. But we got 3 triangles, the real big one, the medium-sized one here, and the smallest one. And I think from the smallest one, you can see that it's definitely an isosceles triangle, because you can see, so I'm going to write that down, triangle VWS is an isosceles triangle because it has 2 equal sides. So I know that I can mark these 2 angles are congruent. So angle WBS must be congruent to angle WSV. So these two, those are the base angles. So Now I've written that one out. Okay, so now let's read the question. First of all, I already read the question, but you haven't. You should always read the question first. I'm a bad example here. Is angle WVS congruent to angle S? Yes, because here's my explanation. Yeah. So that's the explanation. So yes. And now this is not an angle, this is a side. Do you notice how the side has the little bar above it and it has two endpoints? TR. So now we're looking all of a sudden at this big triangle. Is side TR congruent to TS? So this is the side TS. So we're looking at the big. And notice that angle R is congruent to angle V. So these two were given congruent in our thing, and V is congruent to S. So therefore R has to be congruent to S by transitivity. And so if these two are equal, angle R is equal to angle S, obviously we have another isosceles triangle, and therefore those sides are congruent. So now how do we write that up? All right, let me think. Is TR? Yes. So this is also yes. Come on, my pen, work. Doesn't want to. Yes. There we go. Yes to question 2. This is because angle R is congruent to angle, I can't call it angle B, I'm going to call it WVS. WVS, which was given, the drawing showed it. And angle WVS is congruent to angle WSV, as we already established. And therefore, now I'm going to show you a shortcut for therefore. This means therefore, angle R must be congruent to angle S by transitive property. Whoa, I'll just shorten that word. And moreover, we have a new isosceles triangle. TSR is isosceles. So TR, since it's isosceles, must be congruent to TS. Yes and yes. Wow, that's a lot of explaining. Okay, but that really covers all the bases. I'm moving on. This was page 157. We're moving on to the next page. And it is, we're going to do all of those questions up on top. Practice, complete each statement, explain why it is true. So again, we got a complex picture. We have a big triangle. We have the little one here, and we have the second little one here on top. 3 triangles. This is not a triangle. All right, let's look. VT is congruent. So I first make sure I understand what is VT. VT is congruent to VX. And the reason is the base angles are equal, so the big triangle is isosceles. Base angles are congruent. So triangle T. Oh, today is really bad with this writer. Oh, you know what? I need to plug it in. That's what it is. So triangle TVX, the big triangle, is isosceles. Okay, number 2 says UT is congruent to what is congruent to YX. These are sides. UT, I'll look at it, is congruent to, looks like this one, because this little triangle here is isosceles. Notice the 2 base angles. So I'm going to put UW, and then UW is congruent to YX, and that's given because the markings, yeah? So that means triangle, because we're always explaining UTW, UTW is isosceles. And UT congruent to YX is given in the drawing, right here and here. Number 3, VU is, let me look where VU is. VU. Oh, okay. So notice there's no base angle given, but because these 2 sides are equal, that makes these 2 lines here, and these angles are equal, that those are alternate. No, I can't say that. These 2 angles are corresponding. So if these 2 lines are equal, we got 2 parallel sides here. And those 2 angles are corresponding and they're equal. So now I have established that angle, this angle, and this angle are the base angles of this triangle. So VU is congruent to VY. So the reason is angle Y, because angle Y congruent to angle X, corresponding angles, are congruent, and triangle VUY is isosceles. And last, angle. This is the angle symbol. Remember, angles versus sides. Number 4 says angle VYU. So I'm going to look for that angle in my picture. VYU is congruent to angle, this one, VUY. And the reason is base angles, because base angles are equal. Base angles in an isosceles triangle are congruent. Equal. Okay, so this is kind of the parts you have to be able to look at a drawing like that and take all the parts and look at them separate. And sometimes it helps if you actually draw the triangles separate and take them apart, and we'll do that later, and just draw this one out and go, okay, I see now, this is isosceles. Draw this one out, and then it's easier to find all the parts they are looking for. An isosceles triangle has a certain type of symmetry about a line through its vertex angle. So now we have another theorem here. Here's the part you need to know. Make it a little bit bigger. If a line bisects, cuts in half, bisecting is always cutting in half, the vertex angle of an isosceles triangle. So here's the vertex angle. Since these sides are equal, this is your vertex angle. Notice this line, it's a dotted line, cuts this angle in half. So you got two equal angles, left and right of that line. Okay, if that is so, then you have a perpendicular bisector. Perpendicular, remember, is when two lines meet at a right angle. Bisector cuts in half the base. Okay, so this is a lot of information. Let's look at this here. If you have an isosceles triangle, so these two sides are equal, the vertex angle is being cut in half by a line, then this line is perpendicular to the base. There's your 90-degree angle. And moreover, it creates two equal sides, left and right, of that dotted line. Okay, so this is the part that we need to work on next. So make sure you look at that again. I just want you to understand all the wording. Bisecting is cutting in half. Perpendicular means you're meeting, two lines meet at a right angle. Okay. Moving on to the next page, 159 on top. Now we're going to use algebra. I shouldn't say gonna. We're going to use algebra. And remember, when algebra comes into play, a lot of times you see x and y's, and you have to figure out what x and y is. And most of the time we write equations. So I'll make that a little smaller. Okay, let's read it. Suppose measure angle A. Notice we have two triangles and one big one. The big one is isosceles because we have the two markings here. This is a perpendicular bisector. How do I know? We got two equal angles, little tiny bows that are there. So they tell us this angle and this angle are equal in size. So I can actually, if I wanted to, put an X right here because they're equal. Not necessary, but I'm just showing you. So I'm focusing on this triangle right here first. Okay, suppose measure angle A is 20. Actually, I'm going to write this whole picture. And I'm going to make this is my base angle. So I'm going to make that picture up, the right side up so you see it better. So I'm tilting it this way. Maybe not necessary. Maybe you see everything good, but A, B, C. There's my perpendicular bisector. That's a right angle. This is my angle I'm looking for right here. Okay, so let's look. Suppose measure angle A is 27. So that's what I put in here, 27. That's called marking my picture, my drawing. Do that, please. Always do that. What is the value of X? Looking for this number. So look at the big triangle. It's isosceles. That tells me this angle is 27 as well, right? Because they're base angles. Now I'm focusing on this triangle. I'm forgetting this part. You can totally ignore that. Look at the green triangle. I'm going to redraw it. This angle is a right angle. That's the perpendicular. This is the one I want. And this one is 27. So now I'm setting up my equation. Notice that these three angles together are 180. This one is 90. So I can say this plus this has to also equal 90. Because 90 plus 90 is 180. Subtract 27. X is 90 minus 20. Is it 27 or yeah? 90 minus 27 is 63. Yeah, 63 degrees right here. And, or you could do this equation. I'm showing you an alternate. You could also say X plus 27 plus 90 equals 180 and solve that. 27 plus 90 is 117. X plus 117, I think, is equal to 180. Subtract 117. So X equals 180, so it's 3, and then 163. So then this is a little more complicated. To me, this is easier, right? How can you determine the measure of angle C? That's the question here. So this is always a good thing to look at. It's same as angle A because they're base angles. Okay. And moving on, these are not easy, so I want to do all of them. Make sure you understand what's going on or ask in class. So notice we got two triangles and it says find the values of X and Y. So I'm taking it apart. I'm taking this triangle and I'm tilting it this way to separate it. Then that's your vertex angle. These are the two equal sides. And this is your base angle. Right? And this has to be the same as this one. So that's 50. So that's this one. So now I have to find X. So I know two angles. So I add them and subtract from 180. So X is 80 degrees. 50 plus 50 plus 80. This triangle is looking for Y. I'm also making it sideways. You don't have to. This is your vertex angle, 100. This is Y and Y. So I tilt this one that way, yeah, moving it that way. So these two are equal. That's why I say Y and Y, right? Because it's the same angle. So I can name them both Y. So Y plus 100 has to equal 180. 2Y plus 100 has to equal 180. 2Y is 80. I'm skipping a step, and Y is 40. 40 degrees. If this is too fast for you, work it out yourself, okay? So you can do step by step. So that's how you deal with that. You do not have to take it apart and move things around, but you can twist your book if you want, tilt your book, but I want to do that for you for a couple times. This is called an exterior angle. This is your isosceles triangle, correct? So if this is your base angle Y, this has to be Y because they're equal. So the number, whatever Y is, has to be the same here. So this is a linear pair. Linear pair. And the sum is always 180. So 110 plus Y is 180. And then subtract 110. Phi equals 70. So these are 70. And then we need to find x. So this is called the vertex angle. Okay, just to give you an idea, vertex angle, base angles. Okay. All right, so we got 70 plus 70 is 140. Subtract that from 180. So this is 40 degrees. So we have everything. So this is what you probably will be required to do on the homework and on a quiz. A corollary is a theorem that can be proved easily using another theorem. Since a corollary is a theorem, you can use it as reason in a proof. I just want you to know what the word corollary means. It just means an afterthought after a theorem, and you can just attach it to a theorem. Here's a corollary. It just says if, oh, so now we're talking about equilateral. That's like an afterthought of isosceles. By the way, the definition of, I need to look that up, the definition. No, I have to think. I won't say that because I'm not sure about it. If a triangle is equilateral, then it's also equiangular, same angles. So notice our triangle has 3 equal sides, 3 equal angles. Each angle measures 60 degrees. Okay, and backwards, if you have 3 equal angles, you also have 3 equal sides. Okay, so that's the equilateral. So you want to also make yourself a little note to pay attention to this. And we're moving on to the next page. We are on page 160, and we're going to just do number 7. The equilateral triangle and the isosceles triangle shown here share a common side. What is the measure of angle ABC? ABC, this whole angle from here to here, ABC. Yeah. So I'm going to, just to understand the question, I marked that, but I'm going to take this apart. I'm using this triangle first. So I'm taking this triangle, put it here. And these two are equal. And this is angle A, B, D. And this one is 66 degrees. This is the base angle. So then I know this one is 66. So what's this one up here? Measure angle B is 66 plus 66, 132, 180 minus 132 is 48. Yeah. Okay, so this angle is 48. That makes this angle 48. What's this angle? This triangle here is a equilateral triangle. So all angles are 60 degrees. So 60. So the whole angle is measure angle ABC equals 60 plus 48. Remember, the sum of the parts is the total. 8, 1, 5, 5 and 6 is 118. No, did I do that right? No. Why am I having a mental block right now? 60 plus 48 is 108. 108 degrees. There you are. So this is the requirement to be able to understand that. So please read your notes again, check it all out. A lot of information. You are now doing your homework assignment after you look at your notes again. And I want you to circle the questions A and B. You're looking for this angle. Remember, you can tilt the triangle to understand where is the vertex, where are the base angles. The base angles are always these two and they're equal. So you can figure out angle A really easy. Okay, right here. This one is 70. 70, 70. So this one is easy too. And then move on to the next page on top, number 9. A and B. Here you have the vertex and you're looking for X. So remember, these two are both X's. You add 2X plus 30 equals 180. So you can find X using X plus X is 2X plus 30 has to equal 180. Solve. So I'm getting you started here. I'm not helping here. I want you to kind of look at these things yourself. For number 10, you're going to draw your triangle. It's easier when you draw it out. Whoa, stop. The measure of one base angles is 23. What are the measures of the other two angles? You can draw it out to help you. 23. What's this one? And what's this one? This is the vertex angle. These are the base angles. So sometimes a picture helps. And now number 11. What is the relationship? What do you know about isosceles? What do you know about equilateral triangles? And then so we're on page 162, the error. There's an error here, how that person marked the triangle. You need to figure out what the error is. Claudia drew an isosceles triangle. She asked Sue to mark it. Explain why the marking is incorrect. It's incorrect somewhere. You have to explain it. Then go to page 163, and I want you to look at this tower here, this radio tower. There's one in Lakeside. You can go down and look off of Marina Boulevard. There's a radio tower in a farm field. Anyways, you can look at the question and hopefully answer it. If not, we'll go over it in class. And then on the last page, you have 2 more questions, number 30 and 31. These are the ones that are trickier. Okay, you have, look at your notes. This is an equilateral triangle. All the angles are 60. And this is a right triangle. This is a 90 degree. You need to find this angle and this angle. Okay, this is also a 90 degree, notice. So if this is 60, what's left for that angle? All right, good luck to you. See you soon.